Pilot teachers and students, good morning and welcome back to the Education Media Center live classroom telecast in 2004. With the implementation of the new curriculum, the Media Center will support teachers in the outcome-based approach. Pilot teachers, please check the following. Make sure students are in their groups ready for the group activities. When grouping students, please consider gender. Make sure TV monitors are placed properly for students to have better access. Pilot class to follow instruction from the model teacher. Students to take part in the lesson discussion. Write on the blackboard to emphasize a point. Record keyword or phrase on the checklist. And teachers to revise and ask questions to students after TV lesson.
Good morning, pilot teachers, good morning, pilot students, and good morning, class. All right, thank you. You may sit down. Right. Firstly, I'd like to welcome the pilot schools. Now, this year's course, which have been included in the media program, is physics. Now, our first topic, or one of the units that we will study this year, is on scientific notation. Right. The topic is scientific notation. Now, what is scientific notation? All right, I want you to go into groups, all right, as where you're sitting down, you can discuss it among yourself, and then I will ask individual student to give his or her hands up after 2 minutes, okay? So you can do that now. Right, time's up. All right. Sulaiman, your group, what is your definition of scientific notation?
It is a short or easier form of writing numbers and three-dimensional expression.
Okay, Sulaiman is saying that it is a much more easier, or let's say sort of way of writing numbers. Okay. Chose, what about your group? All right, he is saying that scientific notation is simply writing numbers in a much more sort of form using the power of 10. Okay, we'll have a last one, that is Maima. Okay, it is a sort of way of writing small or large numbers. Right, all of those answers are quite correct. Now, simply, when you are measuring any physical quantity, all right, that physical quantity that you measure must have a value and also a unit. Okay. Now, the value may be quite small in a sense that there may be lots of zeros and numbers after the decimal point. That means it is quite small. Now, there may be numbers which are quite big, meaning that lots of zeros and numbers come before the decimal point. That is the reason why we have to write numbers in a much more sort of form, right? Just imagine if you have to write big numbers using this whole board, okay? They may fill up the board, so that is why we have to compress that, right? Simply, scientific notation is using power of 10 in writing a number, okay? It is using the power of 10 in writing a number. All right, we'll now go through and then see how we can write those numbers. Now you'll find that when you write a number, it comes in this form, m times n, or m times 10n, okay, m times 10n. All right, m is simply the number having a non-zero digit and is to the left of the decimal point, right? While n is simply a positive or, right, negative exponent, right? Now what we'll do is to go through, I'll give you the steps in writing scientific notation. All right, that is the explanation of those pronumerals. The m stands for a number having a non-zero digit, n is to the left of the decimal point, while the n is a positive or negative exponent. All right, now to the steps in writing scientific notation. Okay. Right, firstly, you have to determine by shifting the decimal point to the original number to the left or to the right, okay, until only one non-zero figure is left. And the m should be a significant figure, right? So what you can do now is you can go through and then have those the first step in writing scientific notation into your exercise book. Okay, I'll just give you 10 minutes. Yesterday, or you have it already? Okay. You were not here yesterday. Okay, you go quickly through. Right, there are some students who were not here yesterday, so we'll just allow those students to go through quickly. We'll give them time to finish and then we'll go on to the activity. Finish, you finish? you can copy that later. Okay, I will just go. You can copy the next one later on. Okay, Michael, pass the mic on. Yeah, pass it. All right, we will now go through step number 2 of how you can convert or write numbers in scientific notation. Right. Michelle, can you read step number 2? Okay, step number 2.
Determine n by counting the number of places the decimal point has been shifted. If it has been moved to the left, n is positive. If it has been moved to the right,
All right. Okay. Pass it to Maureen. Okay, you finish what has been left over. You can start from 2, step number 2, start from the beginning and then you finish it. Okay, quickly. I stand up. Right, good. So in step number 2, you have to determine n by counting the number of decimal places too. Okay. And if it is to the left, the number becomes, say, positive or negative. Right, it becomes a positive. Right, when it is moved to the right, it becomes a negative. So those are the steps that are involved in writing numbers in scientific notation. Right, I will quickly go through and then give you some examples on that. And then after that, I will give you an activity or 2 questions to do as your activity. All right, those are the examples. You'll find that question number 1 is 0. Right, there are 4 zeros and then 712. And then you are given the number in scientific notation. As we've seen, that number must have only one significant figure, and that is number number 7. It must have only one significant figure, and that is number 7. And also, if you have to count that, you'll find that there are about 6 decimal places that you have moved. Now this time you are moving to the right. That is why it becomes a negative. Okay. All right, quickly have those examples and then I'll give you 2 more questions to solve. Right, finish. finished? All right, now I'll give you one or two exercises to solve. Okay, write that into your book. Convert the following numbers into scientific notation. Right, those are the numbers that you can now convert into scientific notation. All right, you can't do that manually without using calculators, okay? Because when you do that manually, you actually know what you are doing. Calculators can just give you any figures, right? So quickly go through. I'll give you 3 minutes, 1 minute for each of those questions. Finish. Finish. Right, if you have finished, raise your hands. 1, 2. All right, good. I will now pick 3 students to come up to the front and then show your working out, and then probably you can explain to other students who are also watching how you have done that question, okay? Okay, Rachel Master, you do question number 1. Michael Luong, question number 2. And Ume, okay, question number 3. Right, give him the mic. Question number 1 on the board. Okay, you explain while you go through. Okay, come this way. Come stand and then you face. write it quite big. Okay. Make it big, large enough.
I move my decimal point 4 places to the left. So my answer is 3.2704 times 10 to the power of 4.
Right, good. Okay, class, is he correct? Yes. Okay, good. For the first question, that is 32704, you can convert that, and this time, right, from this, the answer is correct. All right. That is the answer to question number 1. Question number 2, right, Michael Luong. Okay, write it quite big so that. Michael, make it large. Okay, quite big.
For the number, the decimal point is moved one place to the right, so therefore your indices is negative 10, negative 10 to the power of negative 1. So the answer is 1.28 times 10 to the power of negative 1.
Class, is that correct? Right, good. The answer is quite correct. When you have 0.128, if you have to convert that to scientific notation, you have only one significant figure, and that is 1.28 times 10 to the minus 1, because you were moving one place to the right. Okay, the last question. Ume. All right, make sure the writing is large enough so that our friends who are watching can also see it clearly.
For this question, decimal places, the decimal point is moved. Decimal place is moved to the left. So the answer is 1.007 times 10 to the power of 1.
Right, is that answer correct? No? Yes. Okay, the answer is quite correct. Right, we have a number which is given that is 10.07, and if you were trying to change that to scientific notation, you simply move one decimal point, and that gives you a significant figure of only a single digit, that is 1. So that is why we have 1.007 times 10 to the power of 1. All right. That brings us to the end of the lesson. Our keyword for today is scientific notation. Once again, good morning, pilot teachers, pilot students, good morning, class. Thank you. Amazing.